What's going on, everyone? So even though the US total eclipse was well over a year ago, April 2024, people still have some lingering questions. And one of the biggest points that seem to be somewhat confusing is how the moon's shadow travels from west to east as we get this eclipse, when both the sun and the moon should be moving or are moving from east to west. So I'm going to try to break that down. So we're using Stellarium here, but let's look at the sun. Every 24 hours, the sun moves up and down about a half a degree, maybe a quarter of a degree, but left and right, not at all. Very, very little. And it depends on the season, time of year there. But we do know that Earth has a sidereal day. We really rotate every 23 hours, 56 minutes, and 4 seconds. Now here's the thing. Everything is moving at slightly different rates. So we have the moon here now, just kind of straight, as close to middle of the evening as I can get. And when we move this in 24-hour time frames, you can see how big of a jump it takes every day. So yeah, next day jumps back pretty drastically. And again, the sun doesn't move back like that. And that's because the moon, to go from the same location to the same location, apparently plus or minus up and down, takes 24 hours and 50 minutes about. So from our perspective, the sun is traveling through the sky faster than the moon. We're rotating and also moving around the sun, and the moon's moving around us. So lots of moving parts there. But in essence, it appears like the sun's moving faster than the moon. So we can model this on computer programs. This here is called Universe Sandbox. If it ever goes on sale, I recommend getting it. I wouldn't pay full price if you're not really into this kind of stuff. But essentially what's happening, we can't see the moon because it's backlit from our perspective here. But the sun there, the moon is there. So the shadow is aiming this direction. Now, as the sun moves faster and overtakes the moon, we're going to rotate it just to get a different angle here. Actually, I won't be able to. Let's do this. We're going to fast forward this. So as the sun appears to overtake the moon throughout the day, and we can even see the shadow moving, then we end up with the shadow going this way, like that. So that is why the shadow appears to move, slow that down, move from west to east. Yeah, this is modelable, testable, demonstratable. I hope that this explained this to anyone that's still a little confused on why the shadow goes from here to here when everything is moving this direction. And really, it's just speed. You could put a ball on a string and pull them at different rates, and watch the shadow move the opposite direction on a far wall. So yeah, thank you for coming to my TED Talk on why the shadow of the eclipse moves from west to east, even though everything is moving east to west in our skies.